Okay, so before we went for the break, we have constructed our mole circle. Okay, so we found the location of our sigma A and sigma B, and the plane that we are analyzing, okay, the XY plane is the one that is the biggest circle. Okay, so now we can calculate our stress average. Okay, we can calculate our stress average. Okay, let me get my size of my page correct first. Okay. Let me copy this whole diagram. So now we can determine our stress average. So where you draw the green line over there. This is our stress average. Okay. So we know that stress X is equal to 0. So the center of the circle, the center of circle, which is our stress average, is equal to stress X plus by stress Y divided by 2, 0 plus by minus 33.953 times 10 to the power 3 divided by 2. So we calculate that our stress average is 33 to the power 953 divided by 2 is 16.977 minus 16.977 times 10 to the power 3 psi. Okay. So now, in order to find, we only know the center of our circle, as you can see down there, right? So what we're trying to find out here is our sigma A and sigma B. Okay, so sigma A B is equal to stress average, which we have, plus or minus our radius. So R is the radius, right, of the in plane circle, which is also equal to our tau max. Okay, so now we have to find, right? We have to find this distance or this value. This is our R, or also known as our tau max, right? So the only way to do this, okay, is we have to apply von Mises criteria, right? Why we have to apply von Mises criteria is because we know the yield strength, okay, right? We know the yield strength. What the top value is dependent on the what? The yield strength of 42 KSI. Okay. So that's the only way you can do this. There's no other way that you can do it. You have to satisfy von Mises. Okay. So von Mises criteria. So we know that the equation is sigma A squared minus by sigma A sigma B plus by sigma B squared, right, has to be less than stress U squared. Okay. So now we're going to put in what is our sigma A and sigma B values. Okay. So if you look at this expression over here, right, we can more or less put everything in to see what sigma A, sigma B is. Okay. Substitute into von Mises criteria. So it's going to be a very wordy expression. So stress average plus by radius squared minus by stress average plus by R multiplied by stress average minus by R plus by stress average minus R squared. This whole thing must be less than stress U squared. Okay. So when we expand the term, we have stress average squared minus also plus by 2 stress average multiplied by R plus by R squared minus by stress average squared. So if you multiply this, you will have plus by R squared. Okay. And then you will have plus by stress average squared minus by 2 stress average R. Then the last one is plus by R squared. Okay. So you can cancel some terms, right? So we know that you can get rid of this term, stress average, you can get rid. 2 stress average R plus minus 2 stress average. Okay. So at the end of the day, what is left standing is your R here, your R here, your stress average squared, and your R, which is good news because we only have our stress average value. Yes or no? We only have our stress average. So the values that we know that we have are our stress average and the yield. Then we can find our R, our radius, which is equivalent to our tau max, right? So from here, mathematically straightforward, 3R squared plus by stress average squared is equal to sigma y squared, or yield, sorry. So to find R is equal to stress U squared minus by stress average squared divided by 3, and then we have to square the whole thing. And this is also equal to our tau max, right? That is also equal to our tau max, which is equal to the radius of our circle. So now all we need to do is to put in the values. 42 times 10 to the power 3 squared minus by our stress average. We found our stress is average minus 16.977. Okay, 16.977 times 10 to the power 3 squared. And then the whole thing divided by 3. Okay, so this is equal to 42 power 3 squared minus by 16.977 power 3 squared divided by 3 square root. You get 22.179 times 10 to the power 3 psi. Okay. So this is our tau max. So if we were to go back to our mole circle, right, we have identified this value over here. we have identified our tau max based on vormesis. Okay. So now we know the radius, which is tau max. So what we want to find is we want to find our shear xy is equal to shear yx, right? So in order to find our shear xy yx, right, we realize that, so what we do know is we know this height now, right? We know this height over here. Right, we know this height. Sorry, we want to find what is our this height. Okay, we don't know what is it. We want to find, right? And what we do know is we know our tau max, and we also know this distance. Okay, so this distance we also know. Right, this distance. We also know that distance, and that distance is 16.977 times 10⁻³ psi. So we have to find our shear xy. Okay, so therefore, shear xy is equal to square root of r squared minus or maximum shear squared minus by your stress average squared. Right? Why stress average? Because 16.977 is also our stress average magnitude. Okay. Or let's not confuse you. Let's put 16.977 times 10⁻³ squared. Okay. So this will be equal to our maximum shear 22.179 times 10⁻³ squared minus by 16.977 times 10⁻³ squared. So the outcome is 14.272 times by 10⁻³ psi. Okay. So from here we can determine the allowable torque. So we know that the shear xy is equal to TR over J, right? So torque in the y direction. Okay. So Tx is equal to 14.272 times 10⁻³. This is equal to Ty. I'm just going to leave R because this is pi over 2 r to the power 4, right? So you cancel r power 3. So Ty, right, is equal to 14.272 times 10⁻³ multiplied by pi over 2 multiplied by radius, which is 0. Or 1.5 divided by 2. So the allowable torque is equal to 9.458 times 10⁻³ pound-inch. Okay, and this is due to vormesis. Okay, so for part B, right? Part B